I built a fully 3D printable Polaroid camera which anyone with access to a 3D printer can just print in a few hours. It doesn't need any electronics, lenses, or special tools. You just print it and you use it to click photos like this. I'm going to show you how it works and we're going to test it out in a bunch of different scenarios, but before we do that, I just wanted to say that when I started designing this camera, I didn't think it would turn out to be this complicated. And let me explain what I mean by complicated. So this piece right here is the actual camera bit of the camera, and it took me about 3 days of work and design iterations to get right. But this weird looking thing over there that the camera can't function without took me a month of work and 9 complete redesigns to get working. And I'll explain what it does and why it turned out that way very soon. But I think at this point you might be wondering, Toast, you're not a 16-year-old upper middle class white girl with a Mini Cooper, so why are you interested in Polaroid cameras all of a sudden? And you'd be right to question my intentions. I am in fact an unemployed caramel colored hobo, but this year I made some New Year's resolutions, and one of those resolutions was to click one Polaroid photo every month to remember the notable things that happened during each month of 2025, and for that I need a Polaroid camera. So I purchased one. Here it is. It's blue and surprisingly voluptuous for some reason, and while I was clicking photographic masterpieces like this shot, I decided to investigate how this camera works, and it turns out that it's much simpler than one would think given that these things start at about $100. These cameras usually use film cartridges like this one, and the shots that these cartridges hold have a photosensitive side, which gets exposed to external light being reflected off of your subject through a lens. Now at this point you might be tempted to pull your shot out of the camera, and if you do that, you'll find that it looks like this, which is a decent shot if your subject is pre-blackface Ariana Grande, but if that isn't the case, then we need to work on developing this film, and for that, there's a delicious concoction of chemicals stored in the bottom bezel of the shot. To make use of these chemicals, the camera has two metal rollers that push this liquid out of the bottom bezel and spread it evenly across the surface of the film, developing the captured image and giving us the final developed Polaroid. Do you see what I mean by the design being too simple? It's basically just a box with a hole in it with two Red Bull cans strapped over it, and this makes me angry. Why did I spend $100 of Terence Grover's hard-earned money on this when I could have made this at home? And that is exactly what we're gonna do today. We're gonna break this build down into two parts, the camera body and the film development module. So let's start with the camera body first. Okay, so since this camera is supposed to be 3D printable, I don't think we can use a lens for this. And no, it's incredibly difficult to 3D print lenses out of clear filament and resin. Believe me, I've tried, and no matter how much you try to post-process the print, it'll always be a blurry, distorted nightmare. And if I wanted to see some weird out-of-focus shapes, I would just eat a spoonful of vapor rub again. So I started doing some research and stumbled upon an article about pinhole cameras. And no, we're not talking about those crappy elementary school project cardboard pinhole cameras. We're talking about proper dialed in pinhole cameras that can take photos like these. I made a very basic prototype to test this stuff out for myself, which should, in theory, project the subject's image onto this piece of tracing paper, and well, take a look. Do you see the problem here? Well, in case you're an audio listener, first of all, what the fuck? Secondly, the issue is that the image is really blurry and dim, which is not ideal for cameras. And no, the image being inverted is not a problem here. If you thought that was the problem, then I highly recommend checking out this resource. As for the blurriness and brightness issue, upon doing some more research, I found out that the size of the pinhole basically dictates how sharp your image is going to be. Think of it like this, you can either have your images looking like Sauron's asshole in 4K with a tiny pinhole, or you can have them looking like the Barbie movie in 240p with a bigger pinhole. And the choice comes down to this. We can fix the image brightness issue by exposing the film for a longer duration of time, but we can't make a blurry image sharp. So I decided to focus on getting a sharper image for now and dialing in the exposure times later. There's a mathematical formula for calculating pinhole sizes, and I'm not gonna bore you with that stuff, but the ideal pinhole size for our use case is around 0.26 millimeters, and it turns out that a hole that small is very hard to get right consistently with an FDM printer. It will show up in the slicer and sometimes it might even print correctly, but most of the time, just like a straight male tourist in a Thai massage parlor, you'll be left wondering about a hole that might not even be there. So instead of 3D printing the pinhole, we're gonna use aluminum foil. You just need a tiny bit of foil so the next time you order a burrito, don't eat all of it, just leave a piece about this big for the pinhole. Now the most reliable way that I've found for creating pinholes for our use case is to use the tip of a regular sewing needle to prick a hole in the aluminum foil. At this point, you might be tempted to ask me, Toast, how do you know that the hole is going to be precisely 0.26 millimeters? After that, I designed this prototype for the camera body. It holds a regular Instax Mini cartridge and has springs in the back to push the film forward like the real thing, and it has a slider which ejects the film for development once you're done shooting. Now some of you might be thinking, how are we going to test if the camera works or not because we don't have a film development module yet? And the answer to that question is this. And no, I'm not just going to throw the prototype away because it's trash. We're actually going to use the trash bag with my Instax camera for film development. Before we do that, we first need to cover up the lens and the flash module of the camera with electrical tape. I'll explain why we're doing this in a second. After this, we need to just take a photo with our 3D printed camera, put it in a trash bag in a dark room, take the film cartridge out, put it in my Instax camera which was already in the trash bag, and then we can just click a photo to get a proper developed shot. Now if you're still wondering why we covered up the lens in the previous step, it's because we don't want to expose the film to any new light. We just want to use the camera for film development. I was able to get some decent quality shots out of this prototype, and please don't worry about the exposure, we still need to dial that in. Here we're just checking for focus and image sharpness. Okay, now that we're done with the camera itself, we need to start working on the film development module. I'm getting Vietnam flashbacks even just thinking about it, but anyway, before we do that, a couple of things. I'm giving away another 3D printer with this video, more about that in a bit, and also a very special thank you to my sponsor for this video, PCBWay. If you guys want to build something, whether it's a robotics project or a mechanical one like this one, or even if it's something more industrial like CNC or 3D printing, whatever you could possibly need, these guys can help. They've helped me with my past projects and their services are extremely affordable for the quality that you're getting with a quick turnaround. So it's a total no-brainer if you're starting a build project of your own. Check them out at the link in the description. Now back to the video. At the beginning of this video, I said it took me 9 complete redesigns to get the film development module working, and frankly, I think it would be a horrible idea to describe each design in detail, so we're just gonna quickly run through these 9 designs and talk a little bit about why each design failed. First up, we have this janky looking design. I call it the strap-on, and the issue with this design was this giant gaping hole between the camera body and the rollers, so the film would get exposed to ambient light before it even reaches the rollers, and every shot would end up looking like this. Some days I'm this close to booking myself a test for mental retardation. This was one of those days. My second design fixes the light leak issue by using an enclosure for the rollers, but here we discover that 3D printed rollers are not very good at spreading out the film development chemical over the film, so most of my shots come out looking like homemade Rorschach tests. With my third attempt, I doubled down on my second design. Instead of 2 rollers, we now have 4 rollers. My thought process behind this was pretty simple. I have a thing that does not work. What if I put 2 of those useless things together? That'll surely work, right? It did not work. For my fourth and fifth iterations, I decided to completely ditch rollers with fixed axes, because as I've learned from these last 3 designs, if the rollers are too close together, they squish the film unevenly and you get modern art like this, but if they're too far apart, they won't be able to pull the film up. So instead of fixed axes, I incorporated springs and one movable axis into this new design. One of the rollers will be on a movable axis being pushed against the other roller by these springs. This will ensure that there's a little bit of give in the system, so ideally we shouldn't see any more of this, while still being able to grab onto the film and pull it up. And it does not work. It's an improvement for sure, but it turns out that 3D printed rollers aren't really perfectly cylindrical. I'm not going to bore you with the specifics, but I tried everything. I tried scarf seams, resin prints, duct tape, paper rolls, double-sided tape, and I even tried replacing the rollers with Posca markers that I stole from a child, but it just doesn't work. I was genuinely disappointed at this point because I was this close to the finish line and it really seemed like I had no other choice than to abandon this project. As a last ditch effort, I made a post asking you guys for suggestions and I got some really decent ideas like converting to Christianity, but this idea from Christopher this one did something to me. It tickled the metaphorical butt cheeks of my brain in a way none of the other ideas did. In theory, this would solve a lot of problems for me because unlike 3D printed rollers, steel rods are going to be smooth and perfectly cylindrical. Also, they won't flex like the Posca markers. So I decided to buy some 8mm stainless steel rods. They're pretty cheap and available basically everywhere. It was going to take a couple of days for my order to arrive because of some logistics issues, but the very next morning, as I was having my nutritious balanced breakfast comprising mainly of potato wedges, I couldn't stop thinking about the camera and the two things kinda merged into one. Vagina? No, that doesn't sound right. Wedges, plastic wedges, 3D printed wedges, like a squeegee. Oh my god, I have to try this out. And so I came up with this rollerless design which uses two 3D printed wedges instead of rollers to develop the film. The only reason that I'm including this is because it sometimes kinda worked, but it wasn't reliable enough, which was fine because at this point my steel rods had arrived and I couldn't wait to try them out. And try I did. In the next couple of days, I made two more designs, and these designs were frankly so dogshit that I actually feel too ashamed to even describe them to you, so I'm not gonna do that. But then finally, I struck gold and came up with this final design. It's functionally very similar to my movable roller design, but because of how thin these rods are, they had to be externally coupled unlike the rollers, and we were able to do that with the help of these two giant churros, gears. Sorry, I haven't had my lunch yet. Also, these rollers disengage now with the help of this thing. So when you click a photo, you need to disengage the rollers like this before you slide the photo up. Once you've slid the photo up, you can re-engage the rollers and then use the crank to develop the film. As much as I'd like to self-deprecate on this channel, I'm genuinely quite proud of this design. And again, thank you Christopher Jehe for the idea. Great, after a month of blood, sweat, and potato wedges, we finally have a working camera. I polished up the prototype and fixed a few minor things, and here's what the final version looks like. Now, I'm not gonna do an assembly montage this time because this video is already too long, and frankly, my attention span has run out, but the assembly and usage instructions will be included with the 3D print files. Anyway, let's test it out. Okay, so I tried it on a bunch of different settings and subjects, and this is what worked the best for me. For indoor shots of subjects within 2 feet with a direct source of lighting like this 12-watt LED panel, a 20 to 30 second exposure, meaning you let the light in for 30 seconds and then close the pinhole up, produces photos like these. You can play around with exposure times and framing, but I'm just giving you a general range for indoor close-ups. As for indoor shots of things that are much further away, you're gonna need quite a bit more light. With two of these 12-watt LED lights illuminating the scene, this is what the final developed shot looked like. You can either use brighter lights or expose the shot for longer. And for outdoor shots, if it's a regular sunny day, the exposure times are going to change drastically and you can get away with half a second to 1 second of exposure depending upon your subject. Now, if you're interested in trying this out for yourself, I feel like I should warn you about a couple of things. First, this is not as plug and play as some of my other projects, so you're gonna have to dial in your settings based on your environment, and that might take a few tries, which means you might need to use up a few shots before you get consistently good results with your setup. Second, 3D printed springs deform over time, especially if you're using PLA, so you might need to reprint the springs every once in a while to keep your film from developing partially. Okay, that's it. You can find the links to the files in the description and consider joining my Patreon if you want to support the channel and get access to all of these other files as well. As for the 3D printer giveaway, I'll just pick a subscriber from the comments section in exactly 1 month from the release date of this video, so there you go. Before I end the video, a special thank you to my Patreon members for being patient with this project. It was genuinely the most difficult project I've worked on so far, so your support means the world to me. Thanks for watching. Like, comment, subscribe if you want to see more stuff like this. As for other stuff, I highly recommend watching this video next. Bye bye. You and I, we are so random. You bring the darkness to the light, split the atom. I ignore the fact that this will never last.